Envision where the stars stop gleaming and systems choose to call it stops. What mysteries could prowl past this newly discovered limit? Are we on the edge of disentangling the best astronomical secret, or is this simply the start of a totally different part in our infinite experience? Well, it appears Webb professes to have tracked down the finish of space itself. Yes, you heard it right, the last outskirts probably won't be so boundless after all. Yet hang on a sec, how might space have an end? Wasn't it expected to continue perpetually? Okay, how about we find out what's, in fact, happening? When I heard this news for the first time, I was completely siphoned up to uncover one of the many secrets of the universe. The James Webb Telescope has been doing precisely that, and it's flipping how we might interpret the universe on its head. In only 12 hours of perception, this wonder showed us things that left us gazing wide-eyed and scratching our heads. Okay, how about we envision together how tremendous the universe really is? Recently, let your imagination roam free and think as far as your brain can go, coming to the very edge of space. Now, we should figure out exactly how much the James Webb Space Telescope can really see out there, the genuine reality. So jump on board our fanciful quick spaceship, and let's not waste any additional time. Now we head to the edge of our planetary group, passing planets like Mars, Jupiter, Saturn, Uranus, and Neptune. We've covered 100 astronomical units, and here we are at the heliosphere limit. Past this point, we enter interstellar space, where Voyager 1 and 2 have wandered. Now we approach the Oort cloud, a mass of space rocks 200,000 cosmic units away from Earth. It's meager, and we easily explore through the space rocks, entering total darkness. Zooming past stars and planets, we arrive at the edge of our cosmic system within the space of minutes. No more interstellar breeze, just brilliant specks of other systems. Planning our course, we realize our universe isn't boundless. It has a limit 10 billion light-years away, and there may be different universes. The unique supervoid, a billion light-years wide, could be proof of an impact with another universe. But how would we get to these different universes? Dark holes may be the key. They're strange, twisting both reality. Some researchers even propose the presence of white holes, something contrary to black holes. The thought is that these could lead to different universes. Remember the Little Bang in 2006? That strange eruption of energy might have been a child white hole annihilated very quickly. Now we should discuss the Andromeda system heading our way at 68 meters per second. Don't panic. It will not crash tomorrow. However, when it gets here, things get fascinating. We could observe heavenly impacts, or maybe our nearby planetary group gets tossed into dark space like a tennis ball delivered on a rope. Fast forward, the galaxies consolidate, and the black holes at their centers start a dance. They eventually merge into a supermassive black hole, emitting energy and a functioning cosmic core apparent for thousands of light-years. Then we have the South Pole Wall, 500 million light-years away, containing a quadrillion stars. There's also the Hercules Corona Borealis Great Wall, a flat superstructure 10 billion light-years wide. And remember the tremendous superquasar bunch, 4 billion light-years across and 6.1 billion times heavier than our Sun? And then there's the perceptible universe, with more than 500 billion galaxies, each with billions of stars. But wait, there's a void called the Eridanus supervoid, or the cold spot, 1 billion light-years wide. Some believe it's a consequence of a crash of universes, two air pockets colliding and tearing material away. Now picture the universe as a giant air bubble, and there may be limitless air bubbles, wormholes, or entries inside black holes. These could be short, easy routes between these universes. Imagine collapsing a piece of paper to connect 2 points without crossing the entire sheet. That's the idea. Discussing black holes, falling into one could be survivable, assuming it's really gigantic. Gravity's impact increases gradually, allowing you to avoid the feared spaghettification. Who knows? Surviving a fall could land you in a different universe with various physics. For the time being, it's just a wild hypothesis. So imagine you're out on a starry evening looking up at the stars. It could appear like they're fanned out equally. Well, incidentally, that's not the situation. All those stars are part of something enormous, an immense vast web connecting galaxies across the universe. Astronomers using the James Webb Space Telescope have just found what could be the oldest strand of this cosmic web ever discovered. Now, let me break it down for you. In 2 papers published in the astrophysical journal Letters, researchers give everything away on this incredible find. They used data from the James Webb Space Telescope to reveal a titanic ring comprised of 10 closely packed galaxies. It extends over a remarkable 3 million light-years. Xiao Fan, an astronomer from the University of Arizona and part of the research group, couldn't contain his shock, saying, "I was astonished by how long and how slender this fiber is. I expected to find something, but I didn't expect such a long, particularly thin structure. It's like accidentally finding a secret old treasure in the enormous vault." This old fiber of gas and stars traces all the way back to a mere 830 million years after the Big Bang, that is, for all intents and purposes, the universe's childhood. And guess what's securing this giant string? A very gigantic black hole, of course. This black hole is no conventional one. It's a quasar, and incredibly bright. Select heavenly article that behaves like the anchor for this grandiose construction. The group behind this stunning disclosure is important for the YERN project. What's a tower? Well, it represents a spectroscopic overview of one-sided radiances in the reionization time. Extravagant name, right? Their mission is to sort out how the earliest dark openings impacted the advancement of cosmic systems and think about what drove them to this old fiber. One of the 25 early universe quasars they had their eyes on is Fei Zhuang, an astrophysicist from the College of Arizona and the brain behind a tower. He is really invigorated. This is one of the earliest filamentary structures that individuals have at any point found related to a far-off quasar. He shouted, "It's like they coincidentally found a huge fortune map uncovering privileged secrets of the universe's initial days." Now here's where it gets intriguing. The scientists feel that dark openings assumed a critical part in shaping this infinite web. Imagine dark openings acting like magnets, drawing matter together with their gravity. However, wait. They periodically hurl stuff far away with what they call grandiose breezes. Gravity is the paste that keeps these strands of stars and dust associated, even as the astronomical winds attempt to pull them across the tremendousness of the universe. So what's the eventual fate of this antiquated fiber? Well, the specialists have a cool idea. They trust that over the long haul, this vast string will gather into a bunch of worlds, similar to the Trans-State Bunch, which is around 330 million light-years away from us. It's like watching the universe advance and make its own multifaceted showpiece over millions of years. When the Webb telescope focused its mirrors on a fix of sky, it saw way more light and way more systems than expected, any worlds as well as large brilliant ones. Now researchers are scratching their heads and coming up with various potential outcomes to make sense of this astronomical mystery. Brace yourself for what I'm about to tell you. These conceivable outcomes are like forks in the road, each prompting new inquiries and understandings. Choice 1. Perhaps stars and galaxies formed in an unexpected way and more proficiently in the early universe. Imagine a dull room without many stars and galaxies, making it simpler for them to shape rapidly. It's surprising, however, it's not a complete rework of what we know. Choice 2. Imagine a scenario in which the brilliance isn't from stars but from very large dark openings. That's right, you heard it right. Rather than a world brimming with stars, we may be seeing galaxies illuminated by these baffling dark openings. But if true, it challenges what we assumed we knew about how many of these beasts existed in the early universe. Choice 3. The most outrageous chance is that our comprehension of the universe's recipe book, called cosmology, is inadequate. It's a bit extremist, but it could shake up our understanding of everything. Choice 4. And then there's the special case choice. There may be some obscure part of the universe that we haven't even considered. Now, why does all of this matter? Well, it's about tracking down our place in the universe and understanding the story of how we arrived here. If we're missing something significant in this story, tackling a puzzle is like doing so without all the pieces. The more we dive into this mystery, the more inquiries spring up. Late discoveries from the James Webb Telescope have given us a reality check about the size of the universe, like we could have been misguided. Researchers dropped a stunner in an ongoing paper, claiming that the telescope got looks at stuff only 120 million years after the Big Bang, if the Big Bang even happened. Additionally, it challenges the very foundation of the standard cosmological model. The universe probably won't be as old as we thought, and what Einstein would call it being boundlessly old, it turns out he came up short. Our instinct has been playing tricks on us, and we're starting to think we really don't have an idea of what's out there. The James Webb Telescope looks into space, trying to see as far as possible, but it can reach about 46.5 billion light-years away. We call that the Hubble span or Hubble circle. And think about what the most far-off world ever found by the telescope, the Macy's world, lived only 450 million years after the Big Bang and is still within this Hubble circle. Now, our universe resembles an inflatable that is continually getting greater. Not only is it growing, but it's also advancing in its expansion beyond the Hubble circle. The universe is extending out quicker than the speed of light, yet the Hubble circle won't continue to develop perpetually. There's an inestimable horizon limit, a fancy term for the recognizable universe. Imagine an enormous non-existent shell around us, 93 light-years wide. That is our limit. The farthest we can see is anything past that? Sorry, not apparent. Yet, even if we had the most insane telescopes, the light from that point simply hasn't touched us. But how huge is the whole universe outside our astronomical shell? Well, we don't know. There are competing hypotheses, and math keeps us on our toes. Some let's assume it very well may be endless, while others toss around numbers like the universe being 10 to the power of 10 times bigger than what we can see. However, the dispersion of matter in the universe and the even spread of temperature in the inestimable microwave background radiation suggest that our universe may be endless. No doubt you heard it right, boundless. Mind blown as of now. When we look into the endlessness of space, we're not just checking far-off galaxies out, we're somewhat looking back in time. Those galaxies we see close to the Hubble circle, they're not depictions of the present. They're similar to astronomical fossils, remnants of a bygone era billions of years ago. It's like having a time machine, but instead of traveling, we're just looking really far. Now, as indicated by our cosmological model, around 14 billion years ago, the whole discernible universe crunched into a minuscule point called the peculiarity. Well, that is the norm story if the universe is limited. However, if it's boundless, which it sort of appears to be, then the Big Bang was certainly not a limited event. It happened everywhere. Now, the first galaxies didn't spring up in an explicit neighborhood of space. They were the universe's great opening demonstration occurring. Wherever, even past what we can see, the central issue, however, kicked everything off. What or who made everything from nothing? Einstein was at first against the possibility of a huge explosion. He loved the idea of a consistent state universe that had been chilling for eternity. Be that as it may, conditions have an enticing method of changing minds, and ultimately he jumped on the Big Bang trend. However, certain individuals, including our friendly scientist describing this infinite story, think the peculiarity is not the beginning, but more like a general birth declaration. Now, when we thought we had the universe's memoir arranged, the James Webb Telescope came and took our breath away. It recently coincidentally found F200dB45, a world that could change vast history. This galaxy is so far away that, if confirmed, it would challenge our comfortable 13.8 billion-year-old universe story. Now, Webb has tracked down universes that shouldn't exist. I'm discussing gigantic worlds appearing only a couple million years after the Big Bang, a cosmic speedrun that challenges our current understanding. Even more stunning, the telescope got early black holes, as it were, 700 million years after the Big Bang. Black holes were combining left and right, potentially explaining how these huge vacuum cleaners filled in their little child years. Now, these discoveries are stirring up some cosmic mayhem in the realm of cosmology. The universe may be older than we thought, or it may not have had a beginning at all. Imagine if our universe is like that favorite storybook that never had a first page. It's forever been there, simply unfolding through various chapters. As we peer further into space, the possibility of an endless universe begins to appear to make sense. If the universe seems boundless in size, why not boundless in age? Perhaps the Big Bang was just a hot wind, not the initial scene, and it's a big but, we need more examination. Does this everlasting universe energy jive with our current scientific understanding? Might it explain the complicated dance of events during the Big Bang? There may be close to 2 trillion galaxies out there, but astronomers are scratching their heads, wondering how much more of the universe is out there beyond what they can see. Virginia Trimble, a cosmologist from the University of California, puts it like this: the universe has forever been slightly bigger than whatever we can see. It's like the universe is playing hide and seek, and we're frantically trying to figure out where it's hiding. John Mather, a Nobel Prize-winning cosmologist from NASA, describes it: we've already seen as far as you might actually imagine. At the very edge, we get a brief glimpse of the flash from the Big Bang. And it's a big but, this isn't as far as it goes. The universe keeps going, and we may just never know how far. In their quest for answers, cosmologists have taken a leaf from the old Greek mathematician Eratosthenes' book. They're attempting to sort out the shape of the universe to tackle the mystery. Think of it like determining whether the universe is a giant saddle, a tremendous circle, or a flat sheet. Now, the saddle-shaped idea doesn't have many fans, but a round universe feels comfortable to us. Einstein named this model a limited yet unbounded universe. However, in the late 1980s, observatories studying the cosmic microwave background radiation dropped a stunner. Incidentally, space has no curvature at all. It's basically as flat as a pancake, or, as John Mather puts it, flat like an infinite piece of paper. So you could travel vastly in any direction, and the universe would look essentially the same. Only universes on the scale of galaxies now are flat. Flat is fabulous for most cosmologists. It fits with both what they observe and the theories they concoct. However, unlike a circular universe, a flat one could be boundless, or perhaps not, and there's no reliable method to differentiate. Virginia Trimble summarizes it nicely: what might you search for to see whether there's an endless universe? No one really knows. It's like trying to figure out if a pizza is infinite or if you'll eventually hit a hard edge. So, you know how sometimes we wonder about the edge of the universe and what would happen if we tried to reach it? It's a marvelous idea, especially when you consider that the universe is apparently limitless. But let's break it down a bit. Okay, so people often say the universe is everything, all of space and time, but is it really part of our universe if we can never connect with it? And what if, past the edge, our universe is entirely different? These are the questions that keep researchers up at night. But consider this: what if the universe isn't entirely flat? What if there's a bend we haven't measured definitively enough? If there's positive curvature, the universe may be the surface of a hypersphere, a 3D surface of a 4D sphere. After all, if we had a warp transport, we could ultimately travel all the way around this curved hypersphere and end up where we started. However, these ideas assume a simplified application of Einstein's equations. General relativity is powerful, but it's not the be-all and end-all. Some theories propose our universe is merely a slowly expanding bubble in a boundlessly swelling multiverse. Bubble universes may be limited in size with a real edge. What's on the other side? Do the laws of physics change? Perhaps not at all. What's the plan? Well, astronomers are hoping for a breakthrough from theory. They want a model that can indirectly demonstrate whether the universe is limitless or not. It's like when physicists predicted the existence of particles like the Higgs boson before finding them. They had this hunch that the particles were real based on their model, and it turned out they were correct. Virginia Trimble puts it in researchers' terms: if you have a good description of everything you've observed so far and it predicts something is true, then you expect it to be. It's the hope that a well-developed theory will point us in the right direction, helping us unwind the cosmic mystery that has been overwhelming our minds since Galileo's first telescope pointed heavenward. Now, here's the thrilling part: you're not just an observer, you can join the investigation. Share your thoughts on these massive discoveries in the comments below. Do you believe there's a secret message in those far-off lights? Or is the universe playing a game of hide-and-seek with us? If you're as fascinated by space as I am, hit that like button, subscribe, and ring the notification bell faster than the speed of light. We'll keep you updated on the latest discoveries and dive even deeper into the mysteries of the universe. Until then, keep pondering, keep exploring, and who knows, you may just be the one to decipher the code of the universe.